radicals, add, subtract, multiply, divide, all of that good stuff with radicals. So hopefully this will be come back to you fairly quickly, but we're going to start with the basics, right? So if I have the number 1 here, 3 radical 100. So remember, the radical is like a square root. So that means that you're thinking what times itself equals 100, right? That's what a square root of 100 means. What times itself equals 100. Now, in this case, 100 is a perfect square, right? We know that 10 times 10 equals 100. So the square root of 100 would equal 10. Now, we're kicking it up right away. If all I had was the square root of 100, then my answer would be 10. But I have 3 radical 100, which means that they're asking us to do 3 times the square root of 100, right? When they're just written next to each other, that means times. So 3 times the square root of 100 is really 3 times 10. And then 3 times 10 would be 30. Okay, so that's the idea, right? Now 100 was a perfect square. But if I look over here at number 2, I have 9 radical 48. 48, that's not a perfect square. And we spent an entire unit last year in 930 talking about what do we do with these radicals that aren't perfect squares. And what we talked about was that we want to take that number, that whatever it is, and break it into its factors, where one of those factors is a perfect square. Right, so I want to figure out what multiplies together to give 48, where one of those things is a perfect square. So I'm sure the first thing jumping out in your head is probably 4 times 12, right? The square root of 4 times the square root of 12 would give me the square root of 48. That's true, but 12 also has some perfect square factors. So you could go this way and then keep working on that square root of 12, right? Or you could and say, okay, well, square root of 12, what multiplies together to give 12? 4 times 3. So I have square root of 4 times the square root of 3. And now I've gotten all the way down, right? Or you could take it and really try to find the factors of 48 with the biggest perfect square. So I know that 16 times 3 also equals 48, and square root of 16 is a perfect square, and it's a bigger perfect square, right? And I get to my answer much, much faster. So really, what you want to do is try to find the biggest perfect square factor that you possibly can. I'll show you how these both work out. I'm going to start with the easier one over here on the right, because now I say, okay, well, the square root of 16, that's 4. I'm going to bring this 9 down out front, right, because this is really 9 times the square root of 48. So I'll have 9 times 4, but then the square root of 3 is not a perfect square, so it has to stay as the square root of 3. It can't change at all, right? Now I have 9 times 4 out in front. If I have those two numbers out in front, I'm multiplying them together. 9 times 4 gives me 36. So I have 36 radical 3 as my final answer. Now, if I look over here on this longer way that I started with, the one that probably jumped out at you first, I see that I have the square root of 4 is a perfect square from this one, right? So I'll bring down my 9. That first square root of 4 in the blue is going to turn into a 2. And then I'm going to have another square root of 4 here, which is also going to turn into a 2. But this square root of 3 at the end here, that's not a perfect square, so it stays how it is, right? And I'm only looking at the ends of my branches here. The 12 has changed to a radical 4 and a radical 3, so the only one I have left here is the square root of 3. And then I could do the same thing and multiply all these together. 9 times 2 is 18. 18 times 2 is 36. So I end up with the same answer, but finding that biggest perfect square possible is definitely easier. It saves you time and it's much less confusing. So really look for those biggest perfect square factors that you can.